Okay, let's go ahead and get started. If there's any complexity in this course, this week will probably be it. This is based on object-oriented programming, and again, I don't want to get too detailed in here, but I would like you to understand how this is done and what experts would do that. So let's keep this light, including your activities that I have you do. Keep it nice. I'm going to try to show you each of these and demonstrate and talk about it. I don't have a lot of experience in object-oriented programming. Have a little bit. I've done a little bit of it, but as far as modeling, back when I modeled, I did not use this because it did not exist. So this is new, based on, as far as I'm concerned, with my experience. My disclaimers: I do not have a lot of experience in object-oriented modeling, but I would like to talk about it because what I did 25 years ago still applies today. It just looks different when you finish up the diagram, but the relationships and everything are still important. Again, I won't spend a lot of time on a lot of this. I'd like you to know that it's popular because it's easy to use without having code. The Python, Perl, again, a lot of this is used in background mode. It's very modular, which means it has a lot of internal subroutines. What are subroutines? Subroutines are code that repeats itself. And so as it repeats itself, instead of trying to re-enter everything that it does, then you, for instance, if you had a subroutine that called for two numbers to be added and the results get sent to another area, and then those results get articulated to another area, then I would write a subroutine for that if it happens again and call it A. And then each time I wanted to do that, I would just put the object A in there, and then you have a subroutine. So again, I'll try to keep it as light and airy as possible. The idea right here, you can see what happens. Again, I like modeling, and I like being able to look at pictures and tell what they do. So this particular one, object, the driver object, is transition into the car that transitions into what happens when the driver pushes the gas or turns the windshield wiper switch, what happens. Again, very simplistic, and that's what we try to keep this done. I've mentioned parents and children before. Let's take a look at this one more time. The parent object, instances of the parent object of what happens when this happens. Instances or occurrences are the same, and you have the lady and the gentleman, the two gentlemen up here, and what's going to happen to them. And then as you transition through, then you can look at the children and see of the characteristics of this right here. Attributes of the characteristics of something. You can keep that in mind as we transition through. Some of the tasks that will happen here, for instance, if you need more fries at a burger joint, then there's certain steps that have to take place, and these have to be listed out. Don't assume that any step is common sense, because sometimes we don't have a lot of common sense, and that becomes a problem. The message and polymorphism. Again, notice the code. Dog causes the dog object to go to sleep, causes the child object to get ready. These are subroutines. I mentioned that before. Classes and subclasses. Not a lot to say about those yet. We'll talk more a little bit about this when we get into future chapters. object-oriented analysis, and I hope you notice without me giving a lot of explanation. Your book does a pretty good job on this. So without me reiterating, if you look and see what class and subclass that these apply to for the superclass, then this simply works its way down to something more specific, from general to specific. Relationships are very important, and this again is used in database work. Relationships have to do what happens. For instance, if I were to define relationships, I would say they are many of you, which means there's multiple students in one class taught by one instructor, me. And so that relationship, it'd be a one to many, one of me, many of you all, or a many to one, many of you all to one to me. You cannot have a one-to-one relationship. I can't describe this class as a one-to-one because it doesn't work that way. Nor can I describe this class as a many-to-many. For instance, there are many of you all, if I had 5 instructors in this class and we were all giving you different assignments, it obviously wouldn't work. Same thing to do when dealing with database relationships. What I just said, relationships among, and I gave you an analogy. This relationships have to do with one social security number to one employee, same as with the telephone. And how this works out. More diagrams. Again, I'm not going to spend any time on UML or the Unified Modeling Language, but look that up, Google that and read about that. It'll help you understand it. Your book does a good definition of this, but if you'll Google the UML and look at its uses, then you will get some ideas of how it's used, and there are several good sites out there to look at. I apologize for dialing through these without deleting them, but I didn't wanted to get down to what we're going to talk about more than anything else. But now, Unified Modeling Language, your book again will do something. A sequence diagram is a flow chart. It's exactly how everything happens. Again, this can become detailed here. When you do the classes, lifelines, messages, and focus, and when you start flowing through here and seeing what this is and seeing what happens here, and then the focus comes over here, this can become confusing. So be careful. Don't let this stress you out. Go out and read about Unified Modeling Language, and this should help you with this right now. Object modeling, student, manager, fitness class, and registration record. Will determine the flow in here. For an example here, the person opens an account, makes a first deposit. If they don't make this first deposit, then it stops here. If they make it, then they go into able to use all of this. But now this account can be frozen for whatever reason, or the customer closes the account and it's closed. This entire process needs to be listed. Notice how simple it is. You all have opened a checking account. This is what actually is written up about the program as it gets defined. Same with you going to the ATM. When you go to the ATM, you enter a PIN, you get your cash. What happens if you don't have the cash? So if you go in here, then you get a message that says you get notified, so you don't get any cash. So the process, just look at the different process. Again, it's just the flow. This has to be put in place here in order for the system to work properly. Business process modeling, I promised you a couple of chapters ago that we wouldn't get involved in this too heavily. But now here's an example of a business process model. Again, you can make this complex or you can keep it simple. You have the applicant, the boss, and the purchasing department, and just kind of trace this through and see what happens when the applicant makes a purchase request, internal, and where it goes. And again, if it's never, the approval's never taken right here, if anything happens. And I hope you can see that computers transition all of this. And if you can never see how all this works, then it gets stopped. And it doesn't work. Let's take a look at the chapter activity. You're going to be doing a case diagram. Keep it simple. And you're going to be doing a state transition diagram. Excuse me. Again, I pulled these off the internet, so that's not clear, and I don't care. You don't really need to read what's in here anyways. I just want to give you an example of what this will look like. Your book also does this slightly different for each of these. I don't care which one you use as long as you can develop a case diagram that identifies what I'd like to have you do. So, again, another quick chapter. Object modeling. It's a technique that's going to be here for a long time, and it tries to keep everything as simple as possible. And then we discuss unified modeling language briefly. I would rather you read about it, though. I think in having me explain that, I may not do a good job of explaining it on what's going to happen with everything. So that's all I have for you. Good day.